So today's workshop is just sort of a kind of a top level overview of data literacy, what we think about around data literacy, and sort of some tips and tricks to get started. So please feel free if you have any questions, please feel free to put them in the chat, raise your hand, any of those. We might have a couple more people joining us later, but yeah, I'm looking forward to it. All right, so just a brief outline of what we'll talk about today. So the first thing we're going to do is start with some definitions. So we're going to define what we mean when we say data and then data literacy. We'll talk about where we might encounter data, some types of data. We'll sort of look at a top level overview of types of data. We'll talk about visualizing data, and then we'll sort of put it all together at the end and sort of give you some questions to think about, to ask about data that you might see throughout your daily life. All right, so the first thing we're going to start off with is some definitions. So when we think about data, what are we talking about? There's a lot of different definitions of data, as you might have encountered. You put 10 different people in a room and you'll likely get 10 different definitions of data or what they think of data as. And this is largely due to folks have different backgrounds, they're in different disciplines, working on different research projects. So their experiences around data are going to be different. But just for today's presentation, we'll use this sort of very broad dictionary definition of data, where this means factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. To put it a little more simply, one can think of data as pieces of information. One thing to keep in mind is data by itself doesn't really have any meaning, right? So it's simply a set of facts or pieces of information, right? So if you have a whole spreadsheet of values, if those aren't arranged in any sort of way, it's just a spreadsheet. Those are just numbers by itself, right? That data doesn't have any meaning until it's been analyzed or used to make calculations. Once it's been arranged into information, so it tells some sort of story. So we encounter data in many places every single day, sometimes without even realizing it. One thing that I'd like you to do, you can put this in the chat or unmute yourself again. Think of one or two places where you have encountered data today or recently. This can be in an academic context or in a non-academic context as well. So think about that for just a second. All right, so any ideas, any thoughts?
I'm a web librarian and I usually use Google Analytics to get the website usage data.
Okay.
Mm-hmm.
Yeah, definitely. That is definitely something we encounter quite a bit, especially if we're doing using analytics for some sort of analysis or improving services or that sort of thing. So here on this slide is just sort of a few examples of places we might encounter data. There's obviously many more than this. But typically we're looking in research articles, maybe back-end analytics about websites or things on the internet, as you mentioned. If we're in a research lab, science lab, maybe we're out in the field collecting data. We also see data in the news or on social media, right? So we see different graphics, pieces of data on there, or maybe on television. We'll talk about this a little bit more later, what to think about when we see this data. Also our mobile apps on our phones, right? Whether that's GPS or one of these other social media apps or anything that we have there, there's data that goes behind those, right? There's data that's constantly being collected there. So we see data in many different places. So data in and of itself, though, is not a new phenomenon. While we think of a lot of data nowadays as digital on the web and on our computers, we've actually been collecting and using data for thousands of years throughout history. And as we know, this hasn't always been digital data, right? So, and our ancestors likely didn't even refer to this information as data. But one example of something we could think of as data is this really cool clay cuneiform spreadsheet that was used to track goods. This is sort of in the form of a spreadsheet. They obviously probably didn't call it a spreadsheet back in 1400 BC. You see it's got the different cells with the different quantities in it, like we might see in a Microsoft Excel file. So this is one example of something that could be thought of as data, right? So we've been keeping track of information and statistics for a long time. And another example of this would be maps, right? We mentioned GPS earlier. So this is a tablet that has a map. And back then they used canals, right? So they used rivers and waterways. And those were sort of their roads back then. You can see that it's sort of gives you a nice directional area for where to go, right? So we could sort of think of this as a precursor to modern maps. And if you're interested, both of these are available at the University of Pennsylvania Museum of Archaeology and Anthropology or the Penn Museum. They have a lot of really cool, artifacts like this that give you some really cool examples if you're interested in looking at more. So now that we've talked about data in and of itself a little bit, let's talk about data literacy. So when we think about data literacy, I really like this definition that we show here. There's a kind of like with data, there's several different ways to think about data literacy, depending on what you're emphasizing. But I really like this definition here. And the very first part that I bolded is kind of the key point. So data literacy is the ability to consume for knowledge, produce coherently, and think critically about data. So there's really three components there, right? So sort of understanding how to work with the data, right? So sort of that statistical literacy piece, right? As we show in the diagram down below. How the data was produced, right? How it was analyzed. And then how to think critically about it. This is sort of similar to how we think critically about information, right, in libraries. So that's why information literacy here is a really, really big piece of data literacy. And when you're looking at sort of the core components of data literacy, you can really pull a lot from those information literacy practices that you might use, if you're doing research in a database. If you go to the library and you're doing research. you'll see some similarities there as we go through. But all three of these components make up data literacy. There's not one or the other that is more important. All three of them are important. So why is data literacy important? So the data that you often see, right, if you're looking at data in its final form in a paper or in a news article or online, that data has been collected, it's been analyzed, and it's been summarized by someone, right? If you're on the back end and you're looking at those analytics, right, you might be that someone that's collecting and analyzing that data. But that final product, somebody has done that analysis. And data in its final form is always meant to sort of tell a story, right? There's always a purpose when you're analyzing data, when you're looking at data, right? So it's important to understand what someone's purpose is when they present data a certain way. A better understanding of data literacy also helps you determine the accuracy and the reliability of data. And being data literate also helps us understand how our data is being utilized by the world around us, right? So, there's a lot of our data out there that's used by our different apps, right? Whether it's a shopping app, grocery app, food delivery app, that's sort of used to help us interact with the world in a more convenient way. And being data literate and having a good idea of how that data is being used and being able to evaluate that really helps us be better stewards of data. All right, I'll just pause briefly just to see if there's any questions. If not, feel free to give me a thumbs up or say that you're good in the chat, and we will keep going. Awesome. All right. So now we're going to go a little bit more into types of data, right? And this is a very top level overview, right? So if you work with a lot of data on a daily basis, some of this might be, you might already be familiar with some of this, but I really like to sort of, put these into kind of broad categories as we're looking at how to evaluate data and analyze data. Now, as we mentioned earlier, there are several different ways to think about data depending on our discipline and our situation. However, data can often be broadly categorized into two different types, quantitative data and qualitative data. Those categories can be further broken down, as shown on this graphic above. And I really like this graphic and how it's set up. And we're going to dive a little bit into each of these different categories and just discuss some discuss a few examples with each of those. So as I mentioned before, sort of the two highest level categories of data would be quantitative and qualitative data. Quantitative data is data that can be measured by numerical variables. It's easily amendable to statistical manipulation. And it answers questions such as how many of something or how much of something. Examples of those could be like how many trees in a given area, a score on a test or an exam, the temperature in the room, etc. Qualitative data, on the other hand, is data that can't be expressed as a number. It can't be measured in the same way that quantitative data can. It's often referred to as categorical data. because the information is often sorted by categories and not by numbers. It often contains words, pictures, symbols. So if you see text data in like a spreadsheet, or if you see interview responses, that's often thought of as qualitative data. This answers questions such as how something has happened or why something has happened. And examples of qualitative data would be colors, or locations or names. Something that can be used sort of to describe something, right? So here we have a nice little picture of birds in different colors. If we're noting the colors, that would be an example of qualitative data. Breaking qualitative data down a little bit further, we have nominal and ordinal data. And the major difference here is whether or not the variables can be ordered, right? So nominal data, that has no intrinsic ordering to the variables, such as high to low, etc. It just names something without applying it to any sort of an order. So like hair color, a randomly generated list of names, right? So that can be thought of as nominal data, whereas ordinal data is ordered in some way. It's placed into some kind of order based on their position on a scale, right? So if we go back to our names example, so if you have top 20 baby names in 2020, that's an example of ordinal data. Or first, second, and third place in the Olympics, when we have gold, silver, bronze medals, that would be an example of ordinal data. It's important to note that you can't do math with ordinal data, even if it is numerical. It only shows a specific sequence. It doesn't show anything that can be statistically manipulated. So thinking a little about quantitative data and breaking that down a little bit further, we have discrete and continuous data. So discrete data cannot be subdivided into parts. It often involves integers with a finite number of values. So the number of people in a room, for example, would be an example of discrete data. We can't have half of a person, right, or a quarter of a person, or the number of touchdowns that would be scored in an American football game. That would be an example of discrete data. Continuous data, on the other hand, is data that can be meaningfully divided into finer levels. So if you have a scale or some sort of a continuum, so like if you're measuring the speed that a car is going down the street, or height, or like a range of temperatures, that would be an example of continuous data. If you're doing like lab analysis, some sort of experiment, that's often thought of as continuous data. All right. So we talked a little bit about some broad categories of data, and that leads us into data visualization. So having your set of data is great, right? So if you're doing some sort of analysis with a data set, or if you're looking at a raw set of data, it's great that you have that, but you really need to take it and represent it in some sort of a way that has meaning, right? Visualizing it somehow so that it's understandable to your target audience. And that's where data visualization comes in. So a data visualization is anything that converts data into some sort of visual representations. It communicates relationships among data points or data sets. And a good representation will make it easier for your viewers, your audience, to analyze and reason about the data and to make logical conclusions. Some common ways that folks visualize their data include statistical graphs, plots, images, and infographics or information graphics. You'll see on the right-hand side, there's just a couple of examples. We have a graph shown at the top right, and then we have an image at the bottom right. So image data is another way to sort of visualize that data or visualize what you're collecting. So for today's presentation, we're going to focus mostly on graphs and infographics, since both of these are used quite readily when representing data in reports and journal articles or news sources. And the first thing I like to do is go over some overall characteristics of what I call good graphs, and then sort of misleading graphs, right? As we mentioned earlier, data, especially quantitative data, is open to statistical manipulation, right? So we like to assume that everyone has good intentions when they're visualizing their data, when they're telling their story with the data. But sometimes, as we'll see in the news, we have to be a little more critical on what an infographic or a graph is trying to tell us. So a good graph will often contain a title. It'll tell you what it's describing. It will label the axes, right? So if you have an XY axis, or even more than that, it'll tell you what each of those mean. It'll tell you what each of the variables mean, so each of the different types of data points. It'll give some sort of a key or a legend or something that gives you an idea of what those variables mean. And it'll also give you a source, right? So it'll tell you where that data came from, right? Where you can get back to the original data set, in case you want to use that for your evaluation. Sort of lends authenticity to that data. If we think about misleading graphs, if we've seen some of those before, if a graph leaves gaps or changes the scale, right? If it sort of changes the axes or manipulates the axes in some way and doesn't really tell you why it did that. If it gives you uneven shading or colors, if there's an unfair emphasis on some sections of the graph, or if it distorts some areas of the graph, if it's really trying to draw your attention to a certain area, right, even if that value may not be all that much different than another one. It may be something we need to look at a little bit further. So now I have a little activity that I like to do in this workshop after kind of talking about sort of good graphs, bad graphs. I have a couple of examples of different infographics, one here and one on the next slide. And what I'd like y'all to do is just sort of take a minute or two, take a look at this graphic, and tell me what you think is wrong here. What stands out to you about this graph? So feel free to think about that for a minute. Put your answers in the chat whenever you're ready. Yes, very good. So we had one answer, which is probably the first thing that you might notice. The percentages here don't add up to 100, right? They go way over 100. And the way that this graph is set up, sort of as like a pie chart, you would assume, right, that this would be equaling 100%. So this is definitely over 100%. So yes, a pie chart is definitely not suitable for this data. And we'll talk about the types of graphs that you would use to represent your data here in just a little bit. And another thing is this pie chart is also split apart, right? So the 73% that I've sort of drawn the arrow to is overemphasized, right? They're really trying to emphasize that section versus even the 69% section or the 46% section, right? And the 73 and 69 are pretty close together, right? Statistically, there's probably not really much of a difference there. So the fact that they're overemphasizing this is a little bit misleading here. And there's no source for this data, right? In this graphic, or even when I was looking at this graphic where I found it, there wasn't a source that led back to the original data, right? So we can't really check what they were trying to do with this particular data, with this particular research question. Great. All right, so here's another example. So this one's a little bit different type of graph. So what is wrong with this particular graph and infographic? Take a minute here and put your answer in the chat, or feel free to unmute yourself and speak if you're comfortable, since we have a pretty small group today. Right. Good. So we take a look at this. The main things to look at here are the axes, right? So we really don't know where the axis starts, right? There's no labels. There's no, it doesn't really tell us where it would start, right? So we might think it doesn't start at 0 because of how the bar graph looks, right? This is very distorted. It takes us sort of 3 grid lines to get up to 6 million, but then it takes us a little bit over 5 to get up to just over 7 million, right? So this is definitely not to scale. This is very much not accurately represented. The difference between 6 and 7 million is only about 15% or so, and you definitely would think it's at least double, if not more, just by looking at this graphic. So our axes here is the really big issue that stands out. Awesome. So, and now we'll talk a little bit about evaluating a data visualization. So we looked at some characteristics of good and bad infographics. sort of saw a couple examples in action. Um, but a lot of graphics, it's not as cut and dry as that, right? Those are some extreme examples, right? Where you can very much tell one or two things that doesn't look right with those graphics. It's often a little bit more nuanced than that. So the proper way to visualize data often varies based on the different context, right? As we mentioned earlier, when we were looking at our pie chart, there's more than one way that you can represent data depending on what question you're trying to answer, right? What information you are trying to get to your audience, right? So when you're looking at a data visualization and you're sort of evaluating it for its accuracy, reliability, there's a few different things you can think about. So the first question would be, is the presenter using the right kind of chart or table, right? So if we look at this example shown on the top right, we see a breakdown of someone's investment portfolio, right? So they have different investments represented as this pie chart. So from this graph, we can definitely tell that they hold a number of investments in different areas, but that's about it, right? It's really difficult to tell if there's any differences or if there's any other information that we're supposed to discern. If we take that same data and represent it with this bar chart shown at the bottom right, now we can see how much is invested in each category, right? We can tell that there's a difference between the percentages of how much of their investments are in international stocks, real estate, etc. So if we're trying to get a glimpse of how much, the bottom graphic would be a better representation of the data. So neither one of them is inherently wrong in any sense. If we're focused on comparing the categories, comparing the amounts, we would want to use the bottom graphic. If you were just trying to show that a certain investment or a couple of investments, make up a large percentage of the portfolio, but the amounts aren't really important, then the pie chart might be okay in that sense. The second question is, do the visuals accurately reflect the data? So you may have seen data before that's represented with a lot of different colors, right? Lots of different shading, tons of labels, fancy effects, such as 3D effects, right? Whether you have a 3D bar chart, 3D pie graph, and there's all kinds of different data there. So this often has the opposite effect of what the presenter is trying to do. It often dilutes the information, especially if there's a lot of information you're trying to present. And it won't captivate your audience. Your audience will have a harder time understanding what you're trying to say. And then the final question would be, what message are they trying to convey? So no matter how the data is presented, the visualization needs to highlight the most important items to ensure the audience can follow the presenter's thought process and focus on the right elements. So with that in mind, we have another example here. So we have two graphics, one on the left and one on the right. So this is votes. This is from an election that took place over in Europe, I think in the UK. But if we're looking at these two graphics and we want to know the total number of votes for each party, which one of these is going to be the better graphic? Which one of these is going to give us that information, give us a better idea of that information? Awesome. One on the right? So these are both pie charts, right? So they're similar type of graphic. The one on the left is a 3D pie chart, whereas the one on the right is a two-dimensional pie chart. Some things you might notice, the one on the left, there's no values, right? So the one on the right has percentages that'll tell us the percent breakdown by each party. So you can definitely tell 53% to 34%. So you can definitely tell who got the highest percentage of votes. The one on the left, you're just sort of inferring this, right? And this 3D representation sort of distorts the graph, right? In this sense, it's harder to get a good comparison of sort of the top percentage and the second percentage, right? Because our eyes are often going to focus kind of on what's in front of us, right? So it's going to really focus on that blue part, right? Or that sort of lightish blue part on the right. And even on that small red sliver there in the middle, and not focus as much as the one in the back. So it's a lot harder to get a reliable sense of the amounts. But if we're wanting to know total percentage, we definitely would look at the one on the right. So these were a couple of different examples of how you can take a data set, how you can take pieces of data and really represent them in different ways. And you definitely want to keep in mind your audience, what information you're trying to get across when you're thinking about which one is appropriate for a certain situation. All right, so before I finish up, just want to pause for a moment again, see if y'all have any questions. If you do, feel free to put them in the chat. If you don't have any, just give me a thumbs up or say you're good, and we'll get through these last few slides. Awesome, thank you very much. All right, so now let's put it all together. The title of the last couple, some of these slides are Put It Together. So we've talked today about different types of data. We've talked about data visualizations, what to look for when we're visualizing data, how to evaluate a data visualization. So let's take all of that and do this one last example, right? So say you find this graphic here on the screen in a research paper or in a news article. And you're curious as to what this is referring to. You want to evaluate this for accuracy, reliability. So where to start and what questions to ask. So some that we might think about is first off, what is the source for this data? Who did the analysis? Just what my mind goes to when I first see a new figure, a new infographic. What is the subject, right? What is this referring to? We see a couple of cities on here. We see axes labels, but what is this referring to? And how should this data be interpreted? What information is the presenter trying to convey? So if we go to the next slide, we'll sort of answer this, right? And I should have had these all come in at different times, but we'll sort of go with it. So who did this analysis, right? This graphic is actually from a research article. It was in the Proceedings of the National Academy of Sciences, published in 2007. And it's actually based on, if we think about what is the source, what kind of data we're looking at, it's actually based on data from the 1918 influenza pandemic, right? So sort of the last pandemic before this current one. the current COVID pandemic that happened and this happened about 100 years ago. And so when we think about what is the presenter attempting to convey, they're comparing death rates over a certain period of time, right, from this influenza epidemic. So they're comparing data from two different cities, Philadelphia and St. Louis, and it gives us a legend, so it tells us what each set of data is represented. And then if we look at this and we're evaluating this, right, we see that one city, Philadelphia, it's big, huge spike, right? This death rate shot way up at the beginning and then sort of leveled off. Whereas the one for St. Louis sort of started small, kind of, gradually plateaued, went up a little bit at the end, and then kind of went down again. So what this actually is, and it's very relevant to our current COVID situation, is the difference is how quickly each city implemented distancing measures. We call them social distancing measures. They may not have used that term 100 years ago, but sort of the equivalent. St. Louis implemented them very quickly, which is why their curve sort of fell off. While Philadelphia did not. You see that huge spike, right? And they didn't level off until there was already a lot of damage that happened. And if we think about this is very similar to the sort of flatten the curve graphic, right? That we might have seen in the news last year when the pandemic first started, right? Back when COVID first started, one of the big reasons for a lot of our distancing measures, mask wearing, was sort of to flatten the curve, right? So that our healthcare system could keep up with these cases. And so we had a graphic sort of like the one at the bottom right. And if you look at the two graphics, they're very similar, right? So this is sort of an example of how we can use data to really sort of extrapolate into what we're seeing now, right? We have different scenarios and different situations, but we have the source data, we have all this really good information, so we can analyze it further to sort of help us evaluate the current situation. And this top figure is actually something that I found after kind of digging into this bottom graphic, right? As a data librarian, I'm really interested in where the data actually came from to make that graphic. All right, so just to wrap up, I like to sort of summarize all this with some questions to ask, right? So when you're looking at any data set, when you're working with data, right, it's important to think about certain things, right? So who is collecting the data? Is it you? Is it another researcher? Who's collecting that? For what purpose are they acquiring the data? What purpose are you collecting website data or anything that you might be working with during your workday, throughout your classes? Who is funding the data collection? This often comes in for research projects at universities. If a researcher gets a federal grant to do research, right? That data collection is partially funded by a public government grant. How large is the sample size? If you're doing collecting field data, if you're doing interviews, how large is your sample? So more data, being able to replicate those experiments, those methods over time, that helps feed some authenticity to the data. And then what is the end goal of the data? What's the purpose, right? So it sort of goes back to that second question, but what's sort of the final aim, the final thing that they're trying to tell you? And then where is the data being disseminated? Where are you seeing it? So that's all that I have to go over today. If you'd like to learn more, there's a lot of different resources out there. If you're interested in diving into data literacy, getting started with data even more, these are some of the resources I used for today's presentation. And there's a few more links throughout the presentation that I pulled for some of the different infographics and whatnot. So please feel free to use these. And we'll send out a copy of these slides later so that you have all of this information. And then I'll go to this first. So if you ever have any questions or you just want to chat, please feel free to send me an email. I am more than happy to talk about anything in this presentation, to answer any other data-related questions that y'all might have. So thank you very much.